In this series of videos, we're going to discuss generics. Now, it's important to note that the general topic of generics is not actually officially covered in 111C. Generics is covered in 211S in much more detail, but we will use generics a lot in our class, so we have to cover it enough so that we can use it. So this week is focused on a sort of very high level or introductory view of generics. And again, we're going to cover just enough so that we can use generics throughout the class, but this isn't meant to be an exhaustive discussion of generics. Again, generics are covered in much more detail in 211S. So what you should get out of this week is enough to be able to use generics with the classes of the Java Standard Library, as well as in classes that you write yourself. So that's what you should be looking to get out of this week. For those of you who want to delve deeper into generics and learn more about it, there's some resources on the lecture notes. And there also, of course, is the next course, the 211S, the Advanced Java Standard Edition, that goes more deeply into generics. So again, we're going to focus really just on enough generics that we can use generics throughout our course here, but we're not going to fully exhaustively cover the topic. So in this particular video, we're going to start with what's kind of the easiest way to use generics, and that's by using generics in the classes of the Java Standard Library. In the next video, we'll move on to using generics in classes that we write ourselves. So in this first video, many of you might have done this already, where we use generics with classes from the Java Standard Library. So this might look like a little bit of a review. That's okay. But I think most likely in the next video, using generics in your own classes will be new to many of you. So we're going to start by using generics in a class that probably many of you, all of you maybe have used, and that's ArrayList. So if we pull up the API page for ArrayList, you'll see that here's the class ArrayList. It's in the java.util package, but you'll also notice this angle bracket E. And this is generics. This is specifying that the ArrayList is a generic class, meaning it has a generic type parameter. Generics is essentially a way to allow a type to vary between different instantiations of that object. So essentially what we're saying here is that we can create an array list that holds one type, like an integer, and then later on in our class or our program we can create another array list that holds a different type, like a string. So the type that we can put into this list is allowed to vary. That's what the generic type parameter does. So you can kind of think about it like we have parameters in our methods, where we have a formal parameter and the value sent into that parameter differs at different times when you invoke the method, right? So the formal parameter of a method, it specifies what type that parameter is, but the actual value changes. So type parameters in a class are a little bit like that. We're saying that array lists can hold different types of objects, and you can specify at different points in your program what that type should be. So you can say, hey, early on in my program, I'm going to create a list that holds integers, and then later on, I'm going to create a new list that holds strings. And both of those objects are array list objects. We've just changed the type of object that's put into that list. Okay, so generics again allow you to vary the type. They create what's called a type parameter. So again, this type parameter is part of the class. It says, okay, you can create a list, and you can specify when you create that list what the type should be. Should it be integer? Should it be string? Should it be JButton? Should it be student? And so on. Okay, so again, this type parameter can vary with every array list object that you create. Now we can think about this type parameter as being sort of a placeholder for a class. So we can use it in all the same ways we would use the name of a class. So for example, if we look down at the methods of the ArrayList class, here we see the letter E as the type of a parameter. So when we call the add method, we're going to send in one parameter, and it's going to be the type of that parameter is going to be whatever type that array list holds. So if that array list holds integers, we send an integer to the add method. If that array list holds strings, we send a string to the add method. Okay, and again, because E is kind of a placeholder for the name of a class, we're used to seeing class names as our formal parameters, right? So same thing here. Here's the other add method where we send in an index and then again an element of type E. Well, what is E? Well, it can be different. It can vary, right? So for one object, it might be an integer. For one object, it might be a string. We can also use type E as the return type. So here's the get method. We send in the index. It gives us back the element at that index. So here we see the return type is E. Well, what is E? It can be different for different objects, right? One array list, if it holds integers, if we invoke get, it's going to send us an integer. And a different array list, if it holds strings and we invoke get, it's going to send us a string. So this placeholder, this type parameter E, can be used anywhere we would normally use a class. Again, it can be used as a type of a formal parameter. It can be used as a return type. Okay? And again, when we instantiate the array list object, that's when we specify or we instantiate that generic type. We say, okay, for this particular list, the generic type, we're going to instantiate it as integer. And for this other list, we're going to instantiate it as string. Okay? So let's take a look at an example of doing just that. So this is a simple little program that's just meant to allow the user to enter in a list of names, and we're just going to then store them in a list and sort them. So pretty simple little program. I just wrote the code right now that just interacts with the user. I haven't actually added the stuff about the list yet. So we could technically run this program right now. It doesn't do anything exciting yet. Just ask the user for the name, reads it in. As long as it's not quit, we'll do something with it. We'll process it. That's the code we're going to add in a moment. And then we will ask the user for another name, read in the next name, and loop back around. One thing to notice in this program is that we invoke the equals ignore case method. Remember that almost always when we compare objects, we want to compare them with the equals method. That applies to all objects, including strings. One additional nice method we have in the string class is equals ignore case. So if you don't care about capitalization, meaning you want to let the user type in capital Q lower UIT but still mean quit, then we can use this equals ignore case. It means basically are the characters the same, ignoring capitalization. Now, of course, sometimes you don't want to do that. You want to literally just the user to have to type in the exact capitalization, in which case you would just use equals. But a lot of times, especially when dealing with user input, equals ignore case is the right method or a good method to use. In general, we don't want to use the double equal sign, but we want to use that equals method. Okay, so this is again the kind of the bones of the program that's going to interact with the user, and now we're going to add the list part. So what we're going to do is we're going to create a list for our names of type array lists. Now I'm going to start without the generics. I'm just going to talk about this for a minute and then we'll add in the generics. Now any generic class, or a class that has a generic type parameter, it does allow you to ignore that generic type and use it without specifying the generic type. What this means is that essentially this list could hold any type of object. So the list could hold a string. It could also hold an integer. It could also hold a student. Okay, so because we've ignored the generics, it essentially says that the generic type is object, meaning we can hold any kind of object. We can hold a string, we can hold an integer, we can hold a student. I would say 99% of the time this isn't what you want to do, right? Typically when you're using some sort of a collection class like an array list, you know what kind of object you want to put in that list. It's usually one type of thing. You're usually collecting strings or numbers or student objects or whatever it is. You're not typically collecting general objects of multiple different types. So again, you can do this, but this is rarely what you want to do. Typically what you want to do is you want to restrict a collection to hold only one kind of thing. So in our case, the kind of thing we want to hold is a string. So in order to do that, after I declare the type array list, I put inside of angle brackets the type. So this now says that that placeholder E, the type parameter, is being instantiated with string. So you can kind of think about it as if everywhere there was an E on this page, it's now been replaced with string. This is a string as a parameter. This is a string as a return type. You can kind of think about it like that. It's really important to note that that's not what's going on. It's not the case that we have two different .class files, an array list for strings and an array list for integers, for example. We only have one, and that compiled bytecode, our .class file, actually ignores the generics. We'll talk a little bit about that in a little bit. But so it's important to know that that kind of search and replace is really not what's happening, but I think it can be sort of useful when you're first starting to understand this to sort of think about it like that. Just make sure you understand that that is not actually what's happening, but it's just kind of a way you can think about it. Well, it's sort of like all of these E's were suddenly replaced with strings. Again, that's not in reality how Java does it, but I think it can be helpful to kind of understand initially what's going on. Now, once we do this, we have to also put the generic type in with our constructor. So we can also put string here before our parentheses. So this now converts our name list into a parameterized type of array list, saying that this name list can only hold string objects. Now note that as of Java 7, you can actually leave the type off of the second angle brackets here. You can just leave them empty and the string type will be inferred. So either one is okay. You can include it in both places or you can leave it off in the second place. Either one is totally acceptable. Note that you don't want to leave off the angle brackets though. You have to have the angle brackets, but your option is either to include string or not to include string. I tend to include it, but again, both are completely optional. Now, what's really nice about generics is once we do this, once we parameterize, instantiate this parameterized type as string, we now have a compile time check that says we can no longer add non-string elements to our list. So now we get a compiler error when we try to add an integer. We get a compiler error when we try to add a student because it says, hey, you can't add an integer to a list that only holds strings. Same thing, you can't add a student to a list that only holds strings. So this is one of the real benefits of generics, is that it puts that type checking at compile time. We always want to resolve issues at compile time. It's much easier to fix them when we're compiling rather than at runtime. Okay, so this is a really nice benefit of generics. One other benefit is, let's say we didn't use generics, and let's say again that we really did intend our list to only hold strings, but somewhere along the way we made a mistake. We meant to add the string, let's say 2. Okay, that's what we wanted to do, but then later on we accidentally added 2. Okay, now this will work because this 2 will be auto-boxed into an integer, so that's why that syntax works. This isn't actually adding the primitive number 2, it's adding the integer 2, so it's like as if you're doing that, but it happens behind the scenes. Okay, now we're allowed to do this because this array list can hold any object, but of course this is a mistake, right? From the programmer side, we didn't mean to do that. We only want to be adding strings. So later on, if I try to get things off my list, if I want to get the third element off, which would be the element in position 2, first of all, I have to cast it to be type string because the compiler has no idea what kind of object is held in my list. So even if I, as the programmer, think that I was very good about only adding strings to my list, I still have to have this cast here to tell the compiler, well, even though this can hold any kind of object, I know it's a string, so I'm going to cast it to a string. So first of all, this is kind of a pain to have to do every time you want to get something off a list. And it also means we can make a mistake because, of course, the element in position 2 is not, sorry, this is maybe a little confusing because there's too many 2's going around. This should be the element in index 2, not the element 2, sorry. But anyhow, this is problematic, right? Because this element in position 2 isn't a string, it's an integer. So when I run this code, I'm actually going to get a runtime error because I'm going to try to cast this integer to a string, and of course those are two different types. I can't do that. So I'm going to get a runtime error. So if I don't use generics, it's a pain because I have to cast every time I want to get something off my list. And it's also troublesome because I could put the wrong kind of thing on my list and then I'll be casting to the wrong type and my program will crash. So all of these are good reasons why we want to use the generics. And then it means that, first of all, we can't accidentally put the wrong kind of thing on our list. The compiler won't let us. And it also means we no longer have to cast things when we take them off the list because the compiler now knows, well, the only object that you were possibly allowed to put in this list was a string. So hey, you don't have to cast it. I know that's what it is. You can just get that off the list and I know that it's a string. Okay. So that's the really nice, those are some of the really nice benefits about using generics. So if we go now into our code here, what we're going to do is when we read in the name from the user, we're just going to add it to our list. Okay, then after we're done reading in all the names, we can use the collections.sort method to sort our name list, and we'll print it back out to the user. So if I run this, I can add in, Jessica, Abby, Zeke, Martin, Jeremy, quit. And it sorts them, prints them out. And again, if we were to want to get an individual item off this list, we could do so. The first name is namelist.getPosition0, and we don't have to cast, again, because we know that only strings were allowed to be put on this list. Okay? So similarly, now here again is an example where we're creating an array list that holds strings, but in another program, let's create a program where we're reading in numbers from the user, and we're going to find the average of those numbers. Okay? So here, we're going to create an array list that holds integers. Okay, so again, this is, of course, I have to import it from the java.util class. So this is, again, still an array list object. So name list is an array list object, and number list is an array list object. They're both of type array list. They're of the same type, but we've just specified that the type parameter is different. So name list can only hold strings, and number list can only hold integers. So that, again, that type parameter can vary between different objects of the array list class. Okay, so here we're going to ask the user how many numbers they want to enter in, and then every time they enter in a number, we're going to add it to our list. Now, of course, if for some reason we had forgotten to, if we'd forgotten to parse this string into an integer and we had just tried to read in the next string from the user and add it to the list, we'll get a compiler error because it says, hey, you're trying to add a string to a list that can only hold integers, and that's not allowed. So again, we have this nice compile time check on the types of objects that we're using. Okay, so we'll read in all the numbers onto our list, and then we will calculate the average. So we'll find the total. And then we will divide by the number on the list. Of course, we could use number of numbers, or we can also use number list dot size. Now, does anybody see any problem with this calculation of the average? Well, let's run our program and see. So here we go. Let's do 5 numbers, and we'll do 1, 2, 3, 4, and 5. It says the average is 3.0. Let's see, this is 3, 4, 5, 6, 7, 8, 9, 10, 15. So that is the correct average. Let's try 5 numbers, 1, 2, 3, 4, 4. It says the average is 2.0. Is that the correct average? You could take a minute and do the math for yourself, but you will find out that no, it is not. The reason is that this is performing integer division because total is an integer and number list.size is an integer, so it performs the integer division, and then it does store it in a double variable, but the integer division has already truncated the decimal. So you got to be really careful whenever you're doing division. 2 different ways to solve this. We could cast one of these operands to type double, or we can always multiply it by 1.0. I'll show you what both ways look like. You don't need to do both. That's overkill. But you can, again, either multiply one side by 1.0 or cast one side to a double. And now we should get the proper average, 2.8. Okay, so again, here's our using generics. This array list holds integers, and the nice thing about that is, hey, look in here, if we hadn't said that this can hold integers, if we hadn't used the generic type inside of this number list, first of all, we wouldn't even be able to use the enhanced for list. For loop rather. We'd have to use a regular old for loop, and then when we took things off that list, it would look like this. So in order to iterate through this list, we'd have to use a regular old for loop, which is fine, but not always as convenient. And then when we wanted to get an integer off it, we'd have to say total plus equals. We'd have to cast it to an integer. like that. So we'd have to do this annoying little cast. And also, of course, in here, if we had made that same mistake that I showed you earlier, that would not be prevented by the compiler. So it allows us to make this mistake. It forces us to do this cast. Again, these are all things we want to avoid. So whenever you can use generics, you want to use generics in your code. And that's just good practice for basically whenever you're using a collections class. You should pretty much always be specifying a type. It's extremely rare that you ever want to create a list of different kinds of objects. Almost always you want to put one type of thing in your list. So when you're doing that, you want to instantiate that generic type parameter to specify this is what's going in my list. And again, the benefit of that is we get that compile time check to ensure that's all that we add on the list, and then we don't have to do any casting when we take off the list. Okay. So there are a couple examples of using generics in the classes of the Java Standard Library, and up next we'll take a look at using generics in classes that we write ourselves.